Hey everybody, in this video we're going to talk about the quadratic formula, and we're going to determine where this quadratic formula actually came from. No, it was not dropped from the heavens to make every math student's life easier when they're working with quadratic equations. It was actually, I think, back in ancient Babylon, they had gone through a process known as completing the square, and they did this and determined that this would work for every single quadratic equation, which is pretty impressive. But in order to get to that actual quadratic formula, we have to complete the square, and we have to start from this general notation: ax squared plus bx plus c equaling 0. So this is saying that for any number, or for any quadratic equation, we've got some constant a, some constant b, some constant c, and then these unknown values of x. All right. So when we go through the process of completing the square, that's generally when our function is not factorable. So if you're not familiar with completing the square, go back to my other videos. I've got a whole video on just completing the square and practicing that. So go there and check that out, and then come back and watch this. It'll make a little bit more sense. So if this general quadratic equation is not factorable, that means we have to go through this process, right? So we first start by getting rid of the negative c. We subtract it from both sides of the equation. And the other big key when you're completing the square is that the coefficient of x squared is 1. So we have to divide both sides by a, which leaves us with x squared plus b over ax equaling negative c over a. Now when we're completing the square, what we're trying to do is get a perfect square trinomial on the left side of the equation. So to do that, we have to look at this middle term, because there's a relationship between perfect square trinomials and the different values within there. And what we found when we looked at that relationship was that if we took this term, b over a, and we divided it by 2, or multiplied it by 1/2, we'd get this result, b over 2a. And if we squared this, we would get the missing link to having a perfect square trinomial on the left side of the equation. So we're going to add that to both sides of the equation to keep everything balanced. Now we can factor the left side, and we get x plus b over 2a squared. And on the right side, we can just start simplifying a little bit. Let's start by multiplying out our b over 2a squared. So a b squared over 4a squared, right? So we just square everything inside there because they're all factors, all multiplying and dividing. So we just square every piece, minus 4ac over 4a squared. Now where did that 4ac and the 4a squared come from? We just had a negative c over a. Well, what I did was I got a common denominator, which I saw was 4a squared, and I thought, what do I have to multiply negative c over a by to get 4a squared in the denominator? And that was 4a. So just multiply the numerator and the denominator there, and we're good to go. So now we can combine our right side and get our b squared minus 4ac over 4a squared. Might start looking familiar if you know a little bit about the quadratic formula at this point. To solve for x, we're going to take the square root of both sides. On the left side of the equation, we get x plus b over 2a. On the right side, we're going to get a plus or minus, because remember, we're taking the square root of an unknown value of x. Anytime you take the square root of an unknown value, you have to consider both the positive and the negative values of that. So we got our plus or minus, and then we have the square root of the numerator, b squared minus 4ac, over the square root of the denominator, which is just 2a. All we did was we took the square root of 4a squared, getting 2a. Move that b over 2a to the other side of the equation, and we have our quadratic formula. Or you might also know it as one big fraction, which is negative b plus or minus square root of b squared minus 4ac over 2a. Alright, so that's our quadratic formula. Let's see it in action. Let's see where this thing what we actually do with this. So we'll look at an example, 5x squared minus 3x plus 2. And we want to look at this and see how we can factor this. If you're not familiar with factoring, go back to the videos on factoring, and maybe that will help some of the conversation that we're about to have. But what we're going to do is we're going to look at the first term and the last term, the coefficient of the first term times the last term. So we're going to multiply those together, we get 10. And we're going to look at the factors of 10 that add up to negative 3. So we get 1 and 10 and 2 and 5. So 1 plus 10 does not equal negative 3. 2 plus 5 does not equal negative 3. Even if we consider the negative values, which wouldn't quite work with this situation, but even if we did consider those, we wouldn't get negative 3. So what we're going to do is we are going to use our quadratic formula by looking at each of the coefficients and constant values in this equation. So we'll start by looking at, well, already dismissed these two. We're going to start by looking at A. So A in our formula, in our specific equation here, is 5. And then we're going to look at B, and B is negative 3. And C is positive 2. So we're going to take these three values and we're going to plug it into the whole quadratic formula. We'll get x equals a negative 3. So right, we've got a negative b. In this case, b is negative 3. So we've got a negative of a negative plus or minus the square root of b squared minus 4ac. So b squared is negative 3 squared minus 4 times 5 times 2. And all that's divided by 2a, which is 2 times 5. So do a little simplifying. We get 3 plus or minus square root of 9 minus 40 over 10. A little more simplifying, and we get 3 plus or minus the square root of negative 31 over 10. Now wait a minute, this square root of negative 31, that's not possible. That gives us no solution. And that actually brings us to some other aspects of the quadratic formula. There's actually some hidden information inside the quadratic formula. And this no solution is just one of them. One thing that you can find in here is this negative b over 2a. This is what we call the x value, or the x coordinate of the vertex. So if you ever want to find the highest peak or the lowest valley of a parabola, of a quadratic equation graphed out, you can find the x value here with the negative b over 2a. We'll discuss this more in future videos. The other thing that's in our quadratic formula is this bit underneath the square root, negative or b squared minus 4ac. This thing we call the discriminant. The discriminant, sometimes also noted as delta, or a triangle there, Greek letter delta. This thing tells us how many solutions we have. If delta is greater than 0, then we have 2 real solutions, or 2 real roots. If delta is equal to 0, then we have 1 real solution, or 1 real root. And if delta is less than 0, then we have no real solutions. And what do I mean by solutions or roots? Well, that's actually where the graph of the parabola of the quadratic equation crosses the x-axis. Okay, so that's what we mean by roots or solutions. So if we like in our example here where we've got negative 31, we can't take the square root of negative 31, so we have no solution. But what do these things look like when we actually graph them? Well, let's take a look at this first one. 2 real solutions would mean, if I can draw kind of a halfway decent parabola here, it's going to look something like this. This is a positive quadratic, and it's crossing the axis at 2 places. So that's the 2 real roots, or the 2 real solutions. Of course, if it's a negative quadratic and it's facing downwards, then you could still have 2 places where it crosses the x-axis. This bottom part here, that's the vertex. That's where we get our negative b over 2a, right? So the x value of that bottommost part. If we want to know the y value, we just take that and plug it into the equation. Okay, so let's look at the second equation, or the second discriminant situation, where if delta equals 0. So what happens there is we might have a graph that looks like this. Now this is a negative parabola, a negative quadratic, but you can see that this thing is only crossing the x-axis. It's actually only touching the x-axis at one spot. And that one spot is also the vertex, the negative b over 2a. Right? So this is the highest most point of that parabola. Of course, if it were positive, it would be an opening. It would be opening upwards, and it would also only be touching at one spot. And finally, the third equation, what does this look like when delta is less than 0, when we have no solutions, like we had in our example in the orange here? Well, what that means is that our parabola is floating above the x-axis, or if it were negative, it'd be sinking below the x-axis. We still have our vertex shown at negative b over 2a, but we don't have any places where it actually crosses the axis. So that's the quadratic formula in a nutshell, and some of the great pieces of information that it will tell us. And in future videos, we'll start looking at how we can use this with our graphs to help graph our functions quicker, and to even come from our graph and create an equation, the equation for the graph as well. So, hope this was informative, and I'll talk to you in the next video.